Hello everyone. So today we are going to solve the subset GOR, which is GFG problems of the day for today. The way I am going to explain this is going to be very easy, but just a small attention I want from you guys. Okay, so in these questions, okay, we have given an n, and okay, and what we have to do, like we have an n, we have to find a subset of a number from 1 to n where both are inclusive, where each number can be mostly used. That means each number can be used at most one time. Okay, now that the GOR of all element in the subset is exactly n, we have to make a subset such that the GOR of all the elements should be n, and the size of subset can be as much large as possible. That means we want to make our subset bigger. Okay, now if multiple subset exist, we have to choose the smaller one. Like suppose this 1 2 is there, 2 1 is there, so we will go for like this value, a smaller value will be passed. So just pay attention, and we are going to decode this in so easy way. We don't look medium too. Okay, now, okay, I think all of us are aware with these things. Like if we are going to find the GOR from 1 to n, then n modulus 4, okay, it is 0. If okay, if n modulus 4 is 0, then GOR from 1 to n is n, and GOR from 1 to n, if that n modulus 4 is 1, then that is going to 1. So GOR of 1 to n is there, so we don't need to go to find the GOR of everyone. We just can find the GOR from 1 to n using this formula. If you want to so that how this works, you can just write like from 8 or 12 or 16 numbers. You will find this pattern easily. Okay, so now what, okay, in our problem, okay, so in our problem now, what is the things, like if we think, like, so suppose from 1 to n, okay, all the things are written, so I don't want to write. Okay, so from 1 to n, if we find the GOR, so then what is that GOR? We are assuming that as a x, so x is the GOR from 1 to n, right? Now, now what we need in our subset, we want that subset which give us n. So we are doing a d can be some element. Okay, okay, some or one, whatever the things is. So x GOR d would be n. Now put d, we do the GOR on each side with x, so x come this way, so d become n GOR x. Now what our task is, like we have to remove minimum digits so that our subset would be maximum. Okay, so now our task is completely on this d. Okay, now if I tell you that this d can be our only one number, okay, that means what if this x is the GOR till GOR of 1 to n, and this one is n. Okay, and that is given already. So if these two are equal to d, so this d could find between 1 to n. That means d would be in our range itself. How we can verify this? Okay, so we know GOR of 1 to n have this 4 formula. With the help of this we can calculate. So if case 1 is, if the n is like, okay, we know that d is n GOR x. Okay, so if the n modulus 4 is 0, okay, so what our x became. Okay, so now this if n modulus 4 is 0, then the GOR value is n, so x become n. Now d is n GOR x. Okay, so x GOR n and x is n, so n GOR n, that is 0. So if n modulus 4 is 0, then that is going to that d is going to be 0. Now if n modulus 4 is 1, okay, so now, so what our the total GOR from 1 to n would be 1. Okay, so x become 1, so this become what, this become 1 GOR this n. Okay, now n, suppose if we take a bigger number like n, okay, and we are going to do the GOR with 1. Okay, now one thing is sure, that n modulus 4 equal to 1, that means last bit must be 1, right? Okay, now if we see all the bit are 0. Okay, now if we do the zeros GOR with 1, then that is going to give you 1. Or if zeros with 0, that is going to be, that means 0 has no effect on GOR. So with 1 it become 1, with 0 it becomes 0. So no bit will get changed accept this last one because this one is 1. So if this is 1, then this is 0, and this cannot be 0. As I said, then n modulus 4 cannot be 0. So this is 1 and this becomes 0. So whatever the our value is, this last bit get changed, its value is 1, so this value get decreased by 1. So this is n, so our d become n minus 1. Okay, right now. So for case 1, this d was 0. For case 2, this become n minus 1. Okay, now for case 3, like if n modulus 4 equal to 2. Okay, now again for 2, that is n plus 1, so n plus 1 jar and n. Okay, so if we talk about n plus 1 jar n, okay, so first things is like n modulus 4 equal to 2. So 4 making 2. Okay, this is right. Okay, this 1 and 0 should be there. This cannot be 1. This 1 and this 0 should be there, whatever the field anything. So why? Because this one is in the power of 4, this one is 8, 16, all should be divisible of 4. Only these two bits are there, which is going to change. And 4 now, as the remainder should be 2, so this should be 1 and 0. Right now, what n plus 1 would be? If this is 1 0, so n plus 1 would be 1 1, correct? What I said, if this one is 1 0, then this n plus 1 become 1 1, because this is 2, then this become 2 plus 1 3. And if we do the jar, so then these all are already same, up to these sections already same, this will going to contribute. Okay, 1 1, then all are same, then that is going to give you 0. This one is also going to give you 0. This are therefore so 1, so the d would be 1 in third case, correct? Okay, now in fourth case, if n modulus 4 equal to 3. Okay, so now this one is 0, so 0 mod n, and that become n. So 4 cases were there. Okay, so if I summarize, okay, I have x, which is the jar of all number. Now if we need d, which I want to remove, okay, so that means that means jar of that number which need to be removed. So d become n jar x. Now I am going to calculate each one, and we find that all of these number are less than n. 0 is there. This is this become n minus 1. Yeah, what is, yeah, n minus 1. This become 1, this become n. All become all came in our range from 1 to n itself. Okay, and in this case 0 is there, we will handle it. Okay, now let's code, we get more clear. Okay, so one value I need to remove from, and we have to return array. So vector of int result of okay, just result, and we are going to for loop int I equal to 1. 1 is included and n is also included. I is less than n, I plus plus. Okay, result dot push back I. Now one value would be skipped. So what could be, like if okay, n modulus, okay, 4 equal to 1. So what our d was? So if we see, so n modulus 4 equal to g, then our d was 0. So we can make a value remove. Okay, so remove equal to 0, right? And we can declare that remove. Okay, minus 1. Why minus 1? Because okay, okay, because if like 3 of the, because we have 1 to n. Okay, and in one case there is a 0. If we see, in one case there is 0, but we have 1 to n. So whenever there is 0, because we are starting our loop from 1, so it automatically minus 1 will automatically skip, like, because whatever our my condition is, like if remove, okay, equal to I, that means if I equal to remove, so we are going to continue. Okay, so even if that is 0, okay, so that is going to continue. So we have make it okay, minus 1. Okay, so if n okay, this 4 condition will be there. So if n modulus this one, if 2 is there, that means if n modulus 4 equal to 2, then this was n minus 1. Okay, and if n okay, and if n modulus 4 was 3, okay, then it was 1, and in last scenario it was n. Okay, I've done some mistake, and one was if n modulus 4 equal to 0, so the move was 0, this was 1. So if we see uh, 0 n minus 1 and 1, okay, 0 n minus 1 1, and last one was n. Okay, so these if this condition, then we need to skip 0. If this condition, we need to skip this one. If this one, we need to skip this one. If this one, this one. Okay, so we have skipped this one, and we are going to save. Okay, now we are going to return result. Now if you talk about this section, this automatically get managed, as we are going to already fill using lexical, so no issue was there. So if we run, okay, if we submit, okay, now if we talk about the time complexity, okay, so if you talk about the space, it automatically was for the return type, so we do not generally can include. So now if we talk about the time complexity, we just move to a one for one loop. Okay, so the time complexity is big of n. Okay, thank you for watching.